Welcome to Mathematics Online Support. I was supposed to make a meeting around 15 hours, but due to poor network, things didn't go as planned. So I'm just going to record a video explaining about limits so that first years should watch. After that, we should discuss some questions. Others who have questions should post in the group. Then I'll be there explaining, solving, and be sharing videos. Yeah, let's go now. Let's start with the main topic, which is limits. So earlier I shared a slide on limits. What I'm going to be doing is that I explain the concept, I give some few examples. After that, we'll try to tackle different types of examples on limits. So, what are limits now? The limit of a function is the foundation of differential calculus. This concept is a central idea that distinguishes calculus from algebra and trigonometry. What does this mean? What this means is that for you to be able to solve calculus problems, you have two types of calculus. You have what we call integration and differential. You first have to know the concept of limits. That's what it means. So let us begin with the informal definition of limits so that we just get some insight on what limits means. So the main topic today is limits. So what are these limits? I'll try to explain this concept in mathematical terms, but I'll try to explain in a language that I will also try to explain in a language that everyone will understand. So let f of x. So let this f of x be defined on an open interval. What I mean is that on this interval, you can pick any value and feed the function f of x so that you get the output. Getting me? So let it be defined on an open interval about a certain value, and we'll call this value x naught. So you have an interval, and then you are defining this function f of x specifically about a certain value, which is x naught. So what will be happening is that if f of x gets arbitrarily close to L, so what I mean is that if you plug in the value, let's say you have an interval, let's call that interval A. This interval it's an open interval. Maybe this interval is from -infinity to infinity, like that. So if you can pick any value, and then you feed the function f of x to give you the output L. Accept that value x naught. If you get this value x naught, it can either be defined or not be defined. So this is what we call limits. So how do we write this mathematically? This means that the limit of f of x, the limit of f of x as x approaches x naught, this is equal to L, some value L. Like I explained earlier, when you get a value in this interval A, accept at x naught, accept that value which is x naught. Except from that value which is x naught, you get that value, you plug in this function f of x, you always get the output L. But what this means, x approaching x naught, is that you'll be picking the values that are close to x naught but not exactly x naught, meaning this function will be defined. So let me just quickly give you an example on the same concept, limits. So suppose you have a function f of x equal to x squared minus 1 x minus 1, like that. F of x is equal to x squared minus 1 over x minus 1. So the question goes like this. Find the limit of this function as x approaches 1, or I can say at x is equal to what? 1. So what does this mean? This means that you find the limit of, as x approaches 1, of this function, which is x squared minus 1 over x minus 1. So how do you go about solving these types of limits? So what you do is, when you're solving any type of limit, the first thing that you have to do is direct substitution. What I mean by direct substitution is, you get that same value of x, the value that x is approaching, you substitute in the function. You see if the function will be defined first. So if you get this value of x, which is 1, you substitute where there is x. You can see that you have a denominator which is 0, and that's indeterminate, or I can say that's undefined. So now you have to do something to manipulate that function, and then you can find the limit. That limit which you are finding is L, just like defined in the definition there, like I explained in the definition, where the limit f of x is approaching, like where f of x, as x approaches x naught, you get that limit. That's what it means. So I can say the given formula defines f for all real numbers. X, so it's defining this function is being defined for all real numbers. Just like I said, previously, let's say you have an interval from negative infinity to infinity. In this open interval, you find that this function is defined for all the values of that are in the interval, except at x equal to 1. That's what it means. So for this reason, for us to solve this kind of limits, meaning you have to factor out the denominator, since the denominator can be factorized by using the difference of two squares. So you can say the limit as x approaches 1, you factorize this one using the difference of two squares. So this will be x minus 1, x plus 1 over x minus 1, like that. You factorize like that. After that, you've observed that you have something which is common, like x minus 1 on the numerator, x minus 1 on the denominator. So these two can cancel. Then you will remain with the limit as x approaches 1, x plus 1. Where you've reached here, you can now substitute the value that x is approaching. So x is approaching 1. When you get that 1, substitute where there is x. You are going to get, when you are substituting, you forget about writing this limit as x approaches 1. Just write the values that you have. So when you substitute that 1 where there is x plus 1, you always get a 0. So in simpler terms, this means that the limit as x approaches 1 of this function is equal to 2. So this defines now the concept of limits. So now, what does this mean graphically? So upon evaluating this limit, we found out that the only part which is defined is this part. So this limit, it's more like this is the graph of x plus 1. And how does the graph of x plus 1 look like? So let's try to graph what we have, x plus 1. So this, you just take it as y is equal to x plus what? 1. So you draw your sketch, your Cartesian plane, your xy plane, you have this, and then here you have y, you have x, like that. So this is a straight line. Let's say you read about how to sketch certain functions in semester 1. So I won't be going step by step, finding the values of y, x, and all those things. No, I'll just use the concept that you learned last semester. So what this means is that this, if you have y equal to x, this is a straight line. I can say this is a line which runs about the origin. It's a line which cuts the origin in this manner. It runs diagonally like that. So it passes like that. But in this case, we've added a 1. The addition of this one simply means it's more like a shift. It has shifted from the origin to the negative sides. How many times? It has shifted one time to the negative side. If it was minus here, meaning it has shifted one time to the positive x-axis. That's what it means. So what this means is that if you have, this is negative 1, this is 1, negative 1, 1, 2, 3, like that. So what this means is that it has shifted to the negative 1, and it's more like the y-intercept which cuts at 1. So you have a straight line which runs in this manner. Like that. So you have this straight line first. Let me just do it step by step so that I don't confuse people. So now, how does the concept of limit influence the graph? If this was not, let me say, if it wasn't for the limits, the normal graph for this function would have been a straight line like this without anything. It would have just been like this and we are done. But because this is the limit that we just evaluated from somewhere, and then we've just graphed the final answer. This is like the final answer. It's more like the limit, because when you just plug in the values, the value that x is approaching, you even get the value which is 2. So just like I gave an example to say, just equate what you have, the final answer of the limit, to y, meaning if you substitute the value of x, what you are getting is the value of y equal to what? 2, like that. So what you are getting here, if you substitute x approaches 1, you substitute there where there is x, you put 1, you are going to have the value of y, which is 2. But meaning, what is the input that is giving the output? It's 1. So when you plug in 1, the output is 2. So this means that at 1, 2, at this point, 1, 2, just, this is a sketch, a rough sketch, so yeah, a big deal. So at 1, 2, at this point, there is what we call a hole. This is called a hole. It's a discontinuity, meaning at this particular point, the function is not defined. This is the limit. You can't reach that point. You keep on approaching that point from this side and this side, but you will never reach that point because that point is a limit. This is what it means graphically.